Hello all, welcome back to yet another problem. And the problem today, let us solve the lead codes daily challenge. The problem is the keys and rooms. There are n rooms labeled from 0 to n minus 1 and all the rooms are locked except for room 0. So what we observe from this is room 0 is unlocked. Your goal is to visit all the rooms. However, you cannot enter a locked room without having its key. Without having its key, we cannot enter the room. So when you visit a room, you may find a set of distinct keys in it. It means that set of distinct keys. Okay, each key has a number on it, denoting which room it unlocks. And you can take all of them with you to unlock the other rooms. So each key has a number on it denoting the which rooms it unlocks, and you can take all of them with you to unlock the other rooms. So given an array rooms where rooms of I is going to have the set of keys and that you can obtain if you visit that room I. Return true if you can visit all the rooms. So what does that denote is? Let us take the example and see. So this is the example 1, and you can see this is the room 0, this is the room 0, and this is the room 1, and this is the room 2, this is the room 2, and this is the room 3. What does that denote is I know that room 0 is unlocked, and I have found the keys for room 1 in room 0. So I can open this room 1. So and I have seen that the room 1 is having the keys for room 2, and I'm also able to open this room 2, and I'm having the keys for room 3, and I'm able to open the room 3 as well. So that is what it denotes. So I can open this room 3, and as you can see that I can open all the rooms by their keys. So that is what they are meaning in this problem. So I'm able to visit all the rooms, and by having their keys, so I can just return true since I'm able to open all the rooms. So let us modify this example itself so that I will be able to give an example for the answer false. So if I change this key number to be 2 and this key number to be 2. Okay. So for this example, I can open this room 0 and I have the keys for room 1. And for this room 1, since I am able to open room 1, I have found the keys for room 3. But for the room 3, I do not have any keys at all in room 3. So I cannot visit this 2 at all. I cannot open this room 2 at all. By this case, I want to return false. So that is it. The problem states. So we want to solve. We want to visit. Ultimately, our goal is to visit all the rooms by opening with their keys. So let's say like this. So this is what the problem states. So how can we solve this problem? So as you can see that uh, 0 is the room which is unlocked initially. So from 0 I can visit all the rooms which that are in room 0, all the rooms that are in room 0. So I have also said that this is going to be distinct keys in each room. So I will be visiting this one. Next what I can do is I can visit this room 1, and I can take all the keys from this room 1. Next I can visit the rooms which I am having, and I can take all the keys. If I can able to reach all the rooms, then I will return true. Hope I'm making sense. What I'm doing is I'm able to visit room 0, and I'm going and taking all the keys that are in room 0, which is 1. Now I am able to visit all the rooms. I can be able to visit this room 1, and I can be able to take all the keys that are in room 1, which is 2. And I can visit room 2, and I can take all the keys which are in room 2, which is 3. And I can visit room 3, and as you can see that I have visited all the rooms 0, 1, 2 and 3, and I can just return true. So this is for example 1. Let us take for example 2. I am visiting room 0, and I am taking all the keys that are in room 0, which is 1. And I am visiting room 1, and I am able to take all the keys that are in room 1, which is 3. But when I visit 3, I am not having any keys in room 3 at all. But after which I cannot go to any of the room. In such a case, I am not visiting this room 2 at all. Room 2 is not visited at all. So by this case, we can just return false. So our starting point is going to be 0, room 0. So these are the observations that we can do from this problem statements. So let us take the example 2. Example 2, these are the rooms and keys. So this is the room 0, this is the room 0, this is the room 1, this is the room 2, and this is the room 3. I am visiting room 0, and I can take all the keys which are 1 and 3. And I am seeing from 1 and 3, I can visit 1 first, and by visiting 1 I can take the keys that are from 1, which is 301. As you can see, 3 I am already visiting, and 0 I have already visited, and 1 I have already visited. I think I don't want to take those. I think I don't want to take all these keys because it is already visited. I don't want to revisit again. I don't want to revisit those keys. So now what I will be doing is, from 1 I don't want to take the keys at all. Next we can open this room 3 as well. From room 3 I can take the keys for 0, but I have already visited this 0 as well, so I don't want to take this key as well. Next the unvisited next the next the there is no room which is visited, and I cannot take these keys. That makes sense because I cannot visit this 2 at all. I cannot visit this room 2, and I do not take this key 2 at all. If I have the key at this I can if I have the key for room 2 at this place, then I can visit this room 1. I can room 1, and I can take this key for room 2, but I am not able to do so because I do not have that key at all. So that is the analysis for this examples. Okay, now how can we solve this problem? How we are going to solve this problem? So I think this has a graph problem, and I'm actually thinking in such a way that how we can visit. So I'm going to use a BFS traversal on these rooms and keys. uh, what I'm going to do is, first I'm going to have a queue, and I'm visiting this room 0. And when I pop this room 0, and I'm going to mark it as visited, and I'm going to push the keys that are not visited into my queue again. So what does that mean is, it is going to go in level wise. So if I'm not visiting this, then I can visit them, and I can push them into the queue. So I can push this. Let us analyze this problem itself. So I have pushed 0, and I am taking the keys from room 0, which is 1 and 3. I will be visiting 1 and 3, and I will be pushing it into my queue. Now I will be popping out 1, and I will be when I pop out 1, I will be visiting the keys which are in room 1. And as you can see, in room 1 I have 301, which is already visited. I don't want to push them again in my queue. So I don't want to push them again. So now what I will be doing is, now I will be popping out 3. If I pop out 3, I am going to visit the keys which are in room 3. So I see that already the 0 is being visited. I don't want to push it into my queue. So my queue is empty and I am not able to visit all the rooms. So that is so that we can say we can just return false. So let us do a BFS on example 1, so that we can say that this algorithm will work. So let us say I'm having a queue and I am visiting 0. When I visit 0, I can take all the keys from room 0, which is 1. Since it is not visited, I will visit 1 and I will push it into my queue. And then when I pop the 1, I want to visit the keys which are in room 1. When I visit the keys which are in room 1, that is the nothing but room 2, I have the keys for room 2, and 2 is not visited. I will visit them and I push it to my queue. Now when I pop this room, when I pop the key for room 2, I will visit the room 2 and I will take all the keys from room 2, which are nothing but 3. I will visit 3 and I will push it into my queue, and I will pop 3 out and I will be visiting room 3. I will take the rooms which are not visited, but it is empty, so that I will not push anything. And as you can see, the queue is empty. I have completed visiting all the rooms 0, 1, 2 and 3. So I can say by this case I can say we can just return true since I have visited all the rooms. So these are the analysis and these are the observations for this examples. So we can make use of this BFS algorithm to solve this problem. So the time complexity, what will be the complexity analysis? The time complexity for the solution will be order of n. So we will be visiting at most once in every room and every keys. So the time complexity will be order of n and the space complexity will be an order of to be specific, we can say the time complexity will be order of n plus b, and the space complexity will be order of n. So to solve this problem using BFS, we need a queue first. We can have a queue, a queue of int q, and I can also have a count which is going to start from 0, because instead of each and every time instead of checking each and every time whether we visited all the rooms, we can have a counter variable to keep track that. And I also need a vector of int visited of size n, and I will say it as 0, 0, 1, 2 and 3. So we can take this size n is nothing but rooms dot size. Now what we can do is, so we have a visited vector that is going to check whether we have visited that particular room or not. Now what we can do is we can visit room 0 by saying q dot push of room 0. Now what we can do is we can also mark it visited. Now while my queue is not empty, and take I'm going to first pop out the front of the queue. So let us say it as current room. Current room is nothing but q dot friend, and I will pop that out. Now I can grab all the keys from the current room. So I will run a for loop for auto key from my current room, that is rooms of current room. I can grab that key only if it is not visited, because I should not revisit that again. So if that is not visited, if that visit of key is, if that room is not visited, let us say it as key itself instead of saying it as room. If this is not visited, let us visit that room. Visit of key is 1. Once we have visited, we can push that room into our queue. So key dot push of room, key dot push of key, queue dot push of key, and that's it. But we want to also keep track whether we have visited all the rooms. So we can say count to be initially 1, because we will be visiting the room 0 initially, so we can have the count to be initialized to be 1. And we can also have a base condition. If my n is equals to 1, then we can just return true, because 0 is always unlocked and we can visit them always. So we can have this base condition, n is equal to 1, we can return true. But as per our constraints, n will be greater than or equals to 2. We don't want to add this base condition at all. We can have this itself. Whenever I am visiting a new room, then I can increment my counter. And I can also have a check here. And I can also have a check in my while loop itself. If my queue is not empty and if my counter is lesser than n, then I can run this while loop and I can just return counter is equals to n by the end of the day. If my counter is equals to n, then I have visited all the rooms and I am able to visit them. So I will be returning true or false based upon that. And it gets accepted. Superb. Let us submit our code. Great, it gets accepted on the first go itself. So the time complexity for the solution will be order of n plus v, which is the n is the number of keys and e is the n is the number of rooms and e is the number of keys. So that's it for this problem, and the time complexity will be n plus e, and n is the number of rooms and e is the number of keys in that particular room, and the space complexity will be order of n. So let us see in tomorrow's LeetCode daily challenge. Until then, bye.